Welcome back again to Advanced Functions MHF4U 1. This is Exponential and Logarithmic Functions chapter. In this lesson number 6, we're going to solve logarithmic equation with one variable algebraically. Let's go over some of the rules, how to go from exponential to logarithmic version. So first, we're given exponential form. The base b of x is equal to y. I could rewrite this as a logarithmic of a log base of b, which is same base, of y is equal to x. Now keep in mind there are some restrictions that the base always has to be greater than 0 and cannot be equal to 1. And x and y has to be greater than or equal to greater than 0. And another way to represent for logarithmic equivalent is when you're given a same base of log b for both sides, then you can equate x and y together. Okay. Keep in mind, again, the base has to be greater than 0 and it cannot be 1, and x and y has to be greater than 0. Now, some of the strategies that you have to remember when working with logarithmic equation. First, you have to rewrite into a decimal or root as a fraction. Okay? So for example, if I'm given 0.2 in terms of logarithm, you're going to write it as 1 over 5. And then you're going to change into exponential form. Another way is when you're given 3 cubed of x, then, so this is the cubic root of x, this will be x to the 1 over 3. And change the log into exponential form. And we're going to use a logarithmic laws to combine the logs. And lastly, you have to make left side and right side express as a single logarithm with the same base. Therefore, you can equate the left side and the right side. Question 1. So we're solving. First, we're given one single log, which is fine, and we're going to change it into exponential form. 3, the base of 3 squared is equal to x. So x is equal to 9. Now keep in mind from the previous slide, we said that x has to be greater than 0. Okay. Next, let's put it in exponential form. X to the 4 is equal to 16. Then we're going to fourth root both sides, so 4 root of x4, 4 root of 16, so they cancel out. X is equal to plus or minus 2. So there are 2 answers. Now, but what do we say? X has to be greater than 0 in order for logarithm to work. So therefore, the only possible answer is x is equal to positive 2. That will be the final answer. Can't be negative 2. Now we're given log, so there's no number for the base, so that means there's invisible 10 here. So let's see, 10 to the power of 3 is equal to 5 minus x. So 10 to the 3 is 1000 equals 5 minus x. So x, if I bring it to the other side, it's going to be negative 995. Okay. Now, what is the restriction for this one? So for this logarithm, it has to be greater than 0. So 5 minus x has to be greater than 0. So therefore, 5 is greater than x. So I'm going to rewrite it. X has to be less than 5 in order for this equation to be valid. So it makes sense. Okay, so this will be my final answer. Next, so we have log 3 base of 2, 2. Oh, sorry. It should be the same base. So I'm going to change it into same base, log 2. Now, assuming that it's the same base, when you're given more than one term, you got to use the logarithmic law to put it into single log. So because it's subtraction, log base of 2, it's 25x divided by 5 equals log 210. So log 2, it's going to be 5, 5, so it's 5x is equal to log 210. Now that the left side and the right side, it's the same base, I can equate it. 5x is equal to 10, x is equal to 2. And that will be my final answer. Okay. So for restriction, for this, we know that it has to be greater than 0, so x must be greater than 0. So that will be my restriction. Letter E. Again, same base. Let's combine it using logarithmic law. Log 2, 3 times x is equal to 3. Now let's put it in exponential form. 2 to the 3 is equal to 3x, which is 8 is equal to 3x. X is equal to 8 over 3. Very good. And for domain, we have x here, so that means x has to be greater than 0. That's my restriction. Okay, now, so we're given this. So we're given only one term of logarithmic form, log. So therefore, I can just go ahead by putting it in exponential. The base of 7, so 7 to exponent of 1 is equal to x plus 1, x minus 5. Therefore, I'm going to do FOIL, front, outside, inside, last, collect the like term. So it's going to be x squared minus 4x minus 5. And then I'm going to bring 7 to the other side. So x squared minus 4x minus 12. And okay, so this is a trinomial, product and sum. So it's going to be 6 and 2. So negative 6 and positive 2, right? So do the trinomial. It's going to be x plus 2, and then x minus 6. And that will give me negative 4 when added. So therefore, x is equal to negative 2 and x is equal to 6. Okay. Now, what about the domain and range? Well, what about the domain? Let's try graphing it. So it seems like we have our zeros at negative 1 because we want x plus 1 and x minus 5 to be greater than 0. So we have domain at negative 1 and domain at 5, and it's greater. So it's a parabola. It looks like this. So if it's greater, that means we're talking about anything that's greater than negative 1 and 5, so over here. And it makes sense. So this negative 2 is definitely greater than beyond of negative 1. So x must be less than negative 1. And then over here, x must be greater than 5. And we do have x is greater than 5 here and here. So that's my domain, my restriction. And these two are my final answer for solving for x. Now we have two terms for logarithmic form, so let's combine into single log. So the base is 10, so log x plus 2 times x minus 1 equals 1. Now let's change it into exponential. So 10 to the 1 is equal to x plus 2, x minus 1. So do FOIL and collect the like terms. So 10 equals x squared plus x minus 2. And I'm going to move 10 to the other side. So 0 is equal to x squared plus x minus 12. And then it is factorable, so it's a trinomial factor. So x plus 4, x minus 3. Okay, so it looks like x can be negative 4, and x is equal to 3. Well, we got to double check. So when you're double checking, you always go back to your original. So the domain, x plus 2 has to be greater than 0. So that means x must be greater than negative 2. For this one, x minus 1 has to be greater than 0. So x must be greater than 1. Okay, so let's see. Does negative 4 belong to within this domain? No, x has to be, so it looks like here. We have 1, and this we have negative 2. X has to be greater than negative 2. This way, and x has to be greater than 1. In this case, we have negative 4 here. Negative 4 is definitely not within this domain, so therefore negative 4 doesn't work. But on the other hand, 3 is over here, so it's still within this domain. So therefore, the only possible answer for this will be x is equal to 3. So when you're solving, after you're done solving for x, make sure you go back to your domain for the restriction if it's belonging to within that range. Now again, we don't like radical, so what I'm going to do, I'm going to change radical into exponent, so x squared minus 21x to power of 1 over 5 is equal to 2 over 5. Then I'm going to change it into exponent form because we only have single log. So 10 to exponent of 2 over 5 is equal to x squared minus 21x to a power of 1 over 5. Now we don't like fraction and an exponent, so I'm going to multiply both sides by 5. So let's multiply this by 5 and this by 5. So therefore, 1 over 5 times 5 becomes 1. And 5 cancels out, so you're left with 2. So you get 10 squared is equal to x squared minus 21x. Now I was able to do that because the denominator was a multiple of 5. So to cancel out the fraction. Then let's collect the like term. So 0 is equal to, so I'm going to move to the other side. So 10 squared, which is 100. So x squared minus 21x minus 100. And you will notice that this is factorable, which is with 25, so 25 and negative 4. So x minus 25, and then x plus 4. So I did trinomial. So it looks like x can be 25, or x can be negative 4. Now, well, let's double check. So we want this, okay, to be greater than 0. So x squared minus 21x greater than 0. So the fifth root doesn't matter because as long as the inside the radicand is greater than 0, that's all that matters. Okay, so then we're going to factor the common factor, so it seems like x minus 21 is greater than 0. Okay, so we know the zeros here. So we have 0 and 21. So 21 and 0. And it's a positive parabola, so it looks like this. And we want the domain to be greater than 0. That means greater than 0 must be this way and this way. So x must be less than 0. Less than 0, right? In order to be greater than 0. So this is the domain. And we want x to be greater than 21 in order to show the red graph, right? Now let's double check. 25 is definitely greater than 21. So this works out. And negative 4 is less than 0. So therefore, we have two answers for this question. Letter I. Okay, so we know that it's a base. So base, x has to be greater than 0. And we know that the base cannot be equal to 1. That's my domain restriction. What I will do is I'm going to change this decimal into fraction. Okay, so that was our number one rule. So log x, so 625 over 10,000. Okay, so change it into decimal. Change the decimal into fraction equals negative 4. So if you're not sure how to change it, all you can do is whatever the number divided by the number of decimals. So in this case, 1, 2, 3, and 4. So you got to divide it by 40. So it will be 10,000. Then I am going to change. So it's a single. So it's x to the negative 4 is equal to 625 over 10,000. Okay. Then you can reduce 625. This becomes 1 over 16. So using your calculator, when you do 625 divided by 10,000, you will get 1 over 16. So hopefully your calculator will be able to change that for you. And then we know that, so we're given x to the negative 4 is equal to 1 over 16. And we can do x to the negative 4, change 16 as a base of 2. 2 to the negative 4. Because this is 1 over 2 to the 4. So I flip it, it becomes negative 4. So you will notice that we have a same exponent. So if it's a same exponent, then x must be equal to 2. Left side equals right side. And that will be my final answer. Okay, last question, letter J. Let's group them using log. So log 7. So because it's addition, I'm going to multiply. 4x minus 1 equals log 7x. Now notice how we have the same log base. If that's the case, then you can equate these two, the logarithm. So it's going to be 3x plus 2, 4x minus 1 is equal to x. So this is rule number 4, I believe, looking at the ones that I wrote down for the strategies. So we just equated it because we have same base. Then I'm going to do the distributive property, front, outside, inside, and last. And then it will be, and then I'm going to bring x to the other side. So it's going to be 12x squared plus 4x minus 2 equals 0. So I collected all the like terms after I've done expanding. And after I simplified, I'm going to see if I could factor. So there is a common factor. So let's factor 2. 6x squared plus 2x minus 1 equals 0. And let's see if I could do trinomial. Okay, so unfortunately, the inside, you will notice that trinomial is not possible. So we're going to use a quadratic formula. And using quadratic formula, x is equal to negative 2 plus or minus 5.29 over 12. Now just a reminder, quadratic formula, x is equal to negative b plus or minus b squared minus 4ac over 2a. So you use this if you have a standard form, a square quadratic that is not factorable. And therefore, so you'll get x is equal to, for this one, for positive 0.27, and for negative, x is equal to negative 0.608. Well, let's double check. So I want 3x plus 2 to be greater than 0. So x has to be greater than negative 2 over 3. And for this one, 4x minus 1 has to be greater than 0. So x must be greater than 1 over 4. And for this one, x is by itself, so x must be greater than 0. Let's double check. So 0.27 is definitely greater than 0 and greater than 0.25 and greater than the negative number. So this is possible. So this is my first answer. But on the other hand, we have a negative. The domain is saying that x has to be greater than 0, but this is negative, so therefore this is not possible. So the only possible answer for x will be 0.27 based on the domain. Now we have a word problem. So a species of bacteria doubles each 10 minutes. The initial number of bacteria is 200. Find the exponential function describing the bacteria population growth. The standard exponential growth or decay formula is y is equal to abx. Y is the final amount, a is the initial amount, b is the growth rate, and x is the time. So if I want to be a little bit more specific, x could be described with the given time over the doubling period in this case. So we understand y is equal to initial amount, so we're starting with 200, and it's a doubling bacteria, so base of 2, and we're not given time, so we don't know how much time we're given, but it doubles every 10 minutes. And this will be my exponential function describing this scenario. Letter B. So find the bacteria population after 1 hour. So 1 hour, because the unit is in minute, 1 hour is 60 minutes. So therefore, y is equal to 200 to so given time is 60 minutes over doubles every 10 minutes. So then you're going to do 200. So simplify 2 to the power of 6 first, which will give me 64. And then multiply by 200, and it will give me 12,800 bacteria after 1 hour. Letter C. Find the time. So now this time we're given time when the population is this one. So this is my final population. So let's plug it in the formula. So we wrote down the formula to be y is equal to 200 to t over 10. So we know the final population, 1, 2, 3, 4, 5, 6 equals 200 times 2 t over 10. So I'm going to move 200 to the other side. So it's dividing. So you're going to get 617.28 equals 2 to the t10. Now again, you will notice that we can't really equate the same base as a base of 2 because we're given decimal. So we are going to take the log to the both sides. Log 617.28, and then you got to do it to the right side as well, log 2 to t over 10. So I'm going to bring exponent to the front, log 617.28 equals t over 10 times log 2. So I'm going to move log to the other side. So it's going to be log 617.28 over log 2 equals t over 10. And then I'm going to bring 10 to the other side. So you're going to multiply. So multiply by 10, and this cancels out. So when you do it, you will get t is equal to 92.70 minutes. Okay, so therefore, find the time. So it's about after 93 minutes, around 93 minutes, that's when the bacteria population will be 123,456 bacteria.